Thank you for joining this presentation. Many of you already know what the managed machine network is. For the people who don't know this and are not familiar with it, the managed machine network is a product we developed to make the industry ready for Industry 4.0 and IoT and managing machines remotely. And I'll start the presentation with a question we asked about 2.5 years ago about where the market is going to go in a few years. The question I ask myself is, how do I prepare my organization for market trends, like machine as a service, Industry 4.0 and IoT? And to be able to ask this question and to get an answer for it, I talked to 50 original equipment manufacturers about what they think they need in 5 years and what they think they need to change in their business model as well. So we developed a product to be able to answer these questions. And what we did, we created the first scalable automated VPN solution to connect your machines in a real-time network. And this real-time network means that you have a real-time connection to every machine at the same time. This is unique because every other product in the market does not have this two-way communication capability to a product, to a machine at the same time. You can connect to a machine, you create a secure connection. It's also a VPN connection, but you can control one machine and then you have to disconnect and connect to another. That's okay for ad hoc if you have a problem and you want to help somebody or you want to work on one machine. But if you look at a large scale, it doesn't work. And the scale is important. Why is it important? If you have a scale solution, you can reduce costs, you can start developing in a much faster methods, so you can increase the lifetime of your machines. And you can create extra functionality after you've sold your machine, after you've placed your machine on the location in the factory or anywhere else. To be able to scale, you have to have a solution which is centrally managed. If you don't have it centrally managed and you have to log in into every location to change settings, it's undoable. If you have 20 machines, it takes you a lot of time. If you have 100 machines, well, once you start it, you can start over again with the first one to change the setting, to update or anything. So you have to have it centrally managed. It also has to be easy to deploy. You don't want to add a machine and work on it for a day to be able to add a machine. You just have to place the modem anywhere and then it's part of the network. You don't have to have any IT skills because people that are skilled in IT and in this industry, they don't have the knowledge. They have the knowledge enough to manage their machine on site and maybe to create a VPN connection and manage it remotely, but they don't have the networking skills to create a secure, scalable solution. So this has to be automated. Well, it's a fully automated VPN, so then you don't have to worry about security, you don't have to worry about routing, you don't have to worry about all the things you need to know if you want to create your VPN yourself. This is very important because if you want to have a network like we create automatically, normally in the IT, this is not even a standard. We send two IT skilled engineers to two locations and they share all kinds of information like certificates, passwords, routing to be able to create this VPN and make it secure. So to be able to automate this was a challenge, but we managed to create it. This network is a real-time network. So it's a many-to-many relationship where any user can access any machine and any machine can access any server in a secure manner. It's a private network where you can add users, servers and machines and they can be centrally managed and accessed in real time. And it's all based on open standards. So there's no lock-in, you can communicate with any device. You can talk to Schneider, but you can also talk to Siemens equipment, to ABB, to any other brand. You can connect any machine, any device with an Ethernet connection to this network and manage it remotely on any protocol. For example, if it has a web browser, you can connect to the web browser. If it has FTP, you connect to FTP, and all at the same time. What does this really mean? Well, if you don't have this network and you want to update a machine, then what you do is you connect to this location. If there is a modem on site, you can connect to it and you have to connect to the machine and then you have to start, for example, Machine Expert, update the software, test if it works okay, and then close the connection and update the second one. Well, that's such a time-intensive process that this is not being done at this moment. Sometimes updates are rolled out, but not on a large scale, and only to fix a problem with one machine and not fix it for every machine because it's not feasible. In a machine network, it's different. In a machine network, you can update one machine or all at the same time. You've got a bidirectional connection to every machine at the same time. So automation of this process is possible. And that's what we did, and that's what we're going to demonstrate in this demonstration. So if you're able to automate it, you can do it by hand. You can start the process by hand. But you can also start it any time during the night if you want to. Why is this important? If you take a look at this example where Volkswagen is retrieving all the electric cars back to the workshop to update the software. And they have a problem in the software and they are asking everybody, can you come back to the garage and we'll update it. It takes about 2 hours and then you can go. And everybody from Volkswagen, they bought this car and they said, oh, well, great, we're going to get new software. I'll gladly go to this garage and great. And the next time they have a software update, they have to come back again. Volkswagen did not think about updating the software remotely. Well, if you're so lucky to own a Tesla, it's different. Tesla updates their software regularly. But one of the updates Tesla did a month ago is totally ridiculous if you think about it. But it shows how Tesla works and thinks about selling a car and then updating it after you've bought it. And the updates they did is they thought, well, somebody asked, is it possible to lock the cupboard where you place your license and maybe some papers with a PIN code? And they said, yes, sure, that's possible. And they added this functionality that if you want to open it, there's a button and says, please enter your PIN code before you can access this compartment. And it's such a small function where you think, well, that's not really that important. But it shows that they have the time to think about these kind of updates. Small updates that really make a difference in how you see updating your machine in the future. This video, what you see here, has gone viral on the internet. And here you see what Tesla does. They update their cars, and once they get this update, the lights start to flicker, and well, as you can see, this is quite amazing. And this video has gone viral, of course, because Tesla has done something no other brand, no other car brand has done before. And they have millions of cars on the road. So why is Tesla the only one that has this functionality? Even the new cars, the new electric cars from other brands, don't have the functionality to update. Okay, in this sheet you can see the machine network a little bit on how it works. You've got all these machines and they've got PLCs, and these PLCs already have IP addresses they use to communicate. And what you see in the industry is that OEM manufacturers use the same IP addresses. And in IT, we already know that's not a good idea, because then it's not possible to communicate with these PLCs because they all have the same address. It's like having a postcard and then not knowing where to deliver it because they all have the same address. And if you get a response, you don't know which PLC responded. So what we did is we created a network over the existing network where every device gets a unique IP address, even if they have an IP address of themselves, which is the same as their neighbor. Once they all have this unique IP address, you can connect to this new IP address, this unique IP address per PLC, and communicate with it all at the same time. So you can also update these machines all at the same time. In the top right, you can see an engineer laptop. He can connect to this network as well via the OpenVPN software, which is an open standard. You can use this software on your laptop, on your mobile phone, on your Macintosh computer, anywhere, and connect to this network and then access these machines. Of course, everything is secure. You can say which devices, which machines, which networks can be accessed by which engineer, and there's a central interface where you can manage the security and make sure that even if you have this network, it cannot be misused. It can only be used for good things. And you don't have to worry about the security because this is centrally managed. And you don't have to have the IT knowledge as well. Because it's very easy. You can just say this engineer has access to this location or this machine or this PLC. In this demonstration, we'll demo a network where we have two locations, a location Amsterdam and a location Rotterdam. And in Amsterdam, we have got a modem and two PLCs connected. In Rotterdam, we've got one PLC. And we also have an engineer with a laptop working in Utrecht. Well, of course, this is a demonstration. To be honest, we're not in Amsterdam, Rotterdam, and Utrecht, but it's all in a separate connection to the machine network. Let me demonstrate on how this looks at our location. Okay, so on the left you see the Amsterdam. So if we zoom into it in the location Amsterdam, we've got two PLCs. From Schneider, and they're connected to a switch and to the modem. And this modem creates a 4G connection to the machine network. You can also connect it to an existing network of a factory or on a location, and then it will do 4G only if the network fails. So it's a kind of automatic failover. And of course, the power supply. And then if you go to the Rotterdam side, we have the same. We have a PLC, one PLC with a modem and a power supply. And I can also show you the location in Utrecht. Yes, we're in Utrecht. And this is an engineer, and he is ready to update these PLCs remotely. So this is what we're going to do. We're going to update these PLCs through the network. And to be able to do this, we worked with some of the people of Schneider to automate this process. So you don't have to connect to the PLC by hand via Machine Expert. You just create an update file in Machine Expert, put it in a special folder, and then start the process. And this process works as follows. Before it starts updating the PLC, it has some prerequisites. For example, it checks if the PLC can be updated. Well, we use Modbus to update it, and we use FTP as well. So we check if these two services are available, and if the PLC is currently in run mode, if it's currently on and working. We also check the firmware version, and this is very important because if you want to update a PLC and you've got a version which is not the same, well, the PLC doesn't allow you to update and breaks if you force it. So we do some prerequisites before we start updating. And then we start the update program. And what we do first, we start with FTP, which stands for File Transfer Protocol. And engineers are aware that you can use FTP to upload a file to an SD card on the PLC. And we use this functionality to upload the new program update. Once this is completed, we download the same file from the PLC to see if it is exactly the same, bit for bit, to be able to verify that the update is correct. Because this is an update to multiple PLCs at the same time, we want to verify that the update is successful and we're not sending a corrupt program file to this PLC, because that would break the machine. So it's a verification process. And once this verification is complete, we'll send an update command via Modbus to this PLC. Well, in the PLC, we've got this program running, and it will monitor if this update command is being received. And once it is received, it knows, okay, I'm going to update myself, and I need to make sure that permanent variables and settings are being saved so I can restore them after the update. And it's going to place the machine in a safe state, so the machine stops working, and if everything is okay, it starts rebooting the PLC and updating itself with the new software. This will take some time, so the program which updates it will wait for the reboot to complete. And then if the PLC has been rebooted, it will check if it goes into run mode. If it doesn't, it will send this specific run command again until it does. Well, this process has been tested more than 100 times, and it didn't fail once. So we're very confident that this will work with Schneider PLCs, where we tested it on in any circumstance. So once this update process is complete, we have got a new program in the PLC. And what we want to demonstrate is that we are going to update the PLC program and add a PT100, which is a temperature sensor, to the program and send this information to Machine Advisor. So this is being added to the PLC, and we also add something to the network, which is called a Node-RED server, which is part of the MMN network. It can only be accessed by the machines, and the Node-RED server can access all PLCs to gather information and send it to Machine Advisor. So you've got this central location where you can manage and retrieve information from any PLC in the network and send it further. For the people which are not familiar with Machine Advisor, I will show you how Machine Advisor looks like. So this is Machine Advisor. Machine Advisor is a product from Schneider itself, and what it does, it can give you insights, information on machines and PLCs, and it can put it in dashboards. And so we created this dashboard where these 3 PLCs, which have not been updated yet and do not send any information about the connected PT100 sensor, because it just isn't part of the program yet. But you can see we prepared the desktop for in case we update the program, then we will see that this information is automatically being sent forward to Machine Advisor. Let me continue with the presentation. Okay, so once we've updated this program, we've got these temperature sensors connected to the PLCs. They are being sent to the machine network. In this machine network, we've got this Node-RED server, which is a gateway which can connect to anything, and they can retrieve the data, the temperature sensors, and send it to Machine Advisor. And the engineering laptop is also connected, and he starts this update process. I'm now going to switch to the practical demonstration where we're going to update these PLCs. So on the left, you can see an automated script which updates the PLCs. And on the right, you can see the PLC itself. So once I start this script, it will read a file on which PLCs it has to update. In this example, we created a network, and every PLC has a unique IP address, and we enter the username and password, where the update file is being located, and what kind of firmware we expect the PLC to have, because if it doesn't match, we will not update it. So once we start this update script, this file will be read, and every PLC will be updated. Does anybody have any questions about this process? You can unmute yourself and ask me before we start. No? Okay, we'll start the process. So we do this in a demonstration where we have to press enter to start the update. Of course, in an automated process, this is not important. This can start automatically. So we pressed enter, and we're going to update the first PLC, and we're going to check if it's ready for an update. So we're going to check if the firmware is okay, if the PLC is running, and if it's ready to receive the update. Well, it's ready, so we're going to start the update now. I've pressed enter, and it's going to transfer the new program file to the PLC. Well, this is done through the network, and once it's been uploaded, we're going to download the same program file and verifying to make sure that it is correct. Well, it seems to be correct, and now we're going to update the PLC. So it automatically shuts down. It receives this command to save all remnant variables and put the machine in a safe state. Then it's going to update the firmware, and then it's going to start automatically. The script, the automated process, is checking if the PLC is coming online. And once it is online and it has verified that the update is successful, we can see this and we can start continuing to update the other PLC. Well, the update is complete. The PLC needed a push to come back in run mode. We did this, and after 2 times we were successful to put the PLC in run mode after the update. So this PLC now has a new program, and what you can see is that we have connected a PT100 to this PLC, and this now sends the information. Puts the information into a Modbus address, which we read and send to a Machine Advisor. So if we hold this sensor, the information will be sent to Machine Advisor. Now, Machine Advisor is an application which only reads the information every minute. So what we will demonstrate is that the information, before it gets into this dashboard, It's also, because we have a real-time connection, it's also possible to see this information real-time. So this is the Node-RED server, and here you can see this is not Machine Advisor. This is not a dashboard, which is able to see a live temperature every second instead of every minute. And here you can see the temperature going up and also going down because we're not holding the temperature sensor again. And every minute this sensor information is also being sent to Machine Advisor. So let's go switch to Machine Advisor and see if the temperature is there. And there it is. So we've updated the first PLC now, and it sends the information we've added to the program of the temperature. So we're going to start updating the second PLC, and the process is exactly the same. We just press enter to start the next update. And what it does, it is the same as the last time. It checks if the PLC is ready for the update, if the firmware is compatible, and then it starts uploading the files, and then comparing the files as well. And then start the update process. It's exactly the same process for every PLC. Okay, the PLC is now rebooting, placing the program in its flash memory, and then starting again and sending the status to us as soon as it is become available. And once that is complete and it's almost done, it has a new program, and it will start to update the PT100 information to Machine Advisor as well. So it's almost ready. And the second PLC has been updated. So let's go back to the Node-RED sensor information, because there we can see that the second PLC is connected now, and we will see in the chart the new temperature of. Okay, and we can see it rising because Gavin is holding the temperature sensor right now, and after a minute we will also see this information in Machine Advisor. Now we're going to update the third PLC as well. And this is in an entire different location. The third PLC is in Rotterdam, and the first two PLCs were in Amsterdam. All right. Well, this is an automated process, so we can go to Machine Advisor and see if the second PLC is already online. Well, it is. And if we wait a little bit longer, we will see the third PLC in Rotterdam also come online and send the information to the dashboard. So here you have an example where you have this machine already in place, and you want to add a sensor, for example, to the program, and then update it. Or maybe you want to improve the program by adding a new check or a new function block which improves the machine in any way. This is all possible with this network. You can connect to the PLCs and update them all at the same time.